Hi everyone, welcome to lesson 5.6. Today we're going to talk about rate of change and finding the average rate of change in a graph. So your aim today is I can determine the average rate of change of a function and use it to compare and contrast. So the first thing we're going to talk about is what is average rate of change. This shouldn't be something you haven't heard before, but we're going to review the idea of it. So this couple sentences is going to start us off. Functions are rules that give us outputs when we supply them with inputs. We know that. That's what we've been working on for the last few lessons. Very often we want to know how fast the outputs are changing compared to a change in the input values. This is referred to as the average rate of change. So we're thinking about how the outputs are changing compared to the inputs. And the way we write this is by saying the change in y over the change in x. Okay, now this seems a little confusing right now, but we're going to talk about it with a couple examples. But I need you guys to recognize that when I type this, change in y over change in x, I am talking about the rate of change. Okay? Let's take a look at an example to help us talk a little bit more about this. So, exercise 1. Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are along in the race in feet is given below, with Max's distance given by m of t and Evie's distance given by the function e of t. So, I'm going to, first of all, I'm going to use different colors to talk about their difference. So let's make this m of t red, and that's Max. And let's say that Evie's is blue. So Evie's is e of t. So this line right here is Evie. I did get a new pen, but I'm still getting used to it. So I got a new pen, but it's still got some issues. Okay? So let me try this again. I'm not really sure where that little e came from. Alright, so e of t is Evie. Okay, this is Evie. And m of t is Max. That's the first thing we have to think about. Okay. Now we got to think about, okay, the y-axis here is what? The y-axis is distance, and the x-axis is time. So let's look at A. How do you interpret the fact that m of 12 equals 30? Illustrate your response by using the graph. Well, if I remember correctly, what is the value that goes inside? That's always your x value, right? So in this case, x is time. So we're going to say at 12 seconds, what is the distance? 30. At 12 seconds, someone's going 30 what? Feet. Who's going 30 feet? What graph goes with m? Max. So at 12 seconds, Max is 30 feet in the race. That's what this function notation means. So that's time, and the 30 here is your distance. Okay? Letter B. If both runners start at t equals 0, how much of a head start does Max give his little sister, and how can you tell? If I look on the graph, here's 0. They're both starting here. Max is starting here, so there's Max's starting point. Where's Evie's starting point, though? Evie is starting way up here, correct? So, I'm still trying to figure out how to... I don't know how to erase on this new pen. That's a little frustrating. Okay, well, I'll have to figure that out. Okay, so Max is starting at the red dot, and Evie is starting at the blue dot. So this is saying that Max is starting where? Max is starting at 0 distance, because he's starting at the origin. So Max is starting at 0. But where is Evie starting? She's here 10, 20. Evie is right here at 25. So Max is starting 0 distance, and Evie's starting 25. So how far of a head start did Evie get? She got a 25-foot head start. Even though they're both starting at the same time, she is starting at 25. So she starts at 25 feet. He starts at 0 feet. So she has a 25-foot head start. How did I figure that out? Well, I basically did 25 minus 0 equals 25. I took where she was and where he was and subtracted it. I got 25 minus 0 equals 25. That's how you can find rate of change, by subtracting. Does Max catch up to his sister? No. He does not catch up to his sister. Catching up would mean that Max would have to be at the same place at the same time as Evie, right? When you catch up to somebody in a race, you both hit the same time in the same place. If I look at these two graphs, do either of these two lines that I'm highlighting ever touch each other? No. These two people never, ever, ever cross at the same time at the same place. So no. He never catches up. He never catches up. They never share the same distance in the same place. Okay. All right. Keep going. How far does Max run? So this says how far. So we're looking at distance. How far does Max run during the 20-second race? So let's look at Max's line. So Max, let's see, Max starts at 0. He starts at 0 feet. And where does he end? Let's look. He ends right here, which lines up with 50. So he starts at 0 feet and ends at 50 feet. So he went 50 minus 0 to get, he went a total of 50 feet in the race. Started at 0, ended at 50, he went a total of 50 feet. Evie, now the next part of the question asks, how far did Evie run? Well, Evie didn't start at 0. Where did Evie start? She started at 25, right? So she starts here at 25, and where does she end? She ends here on the, I'm pointing at the graph now, she ends up here at 60. So she starts at 25 feet and ends at 60. So to figure that out, I subtract again, right? If I want to find out the total distance of something, I have to subtract the end with the beginning. So she went 60 minus 25 to get me 35 feet. So she ran a total of 35 feet, and Max ran a total of 50 feet, sorry. Okay? And keep in mind, whenever you have questions on your notes, mark it in your notes and then come ask me, Ms. Vasquez, in class. Letter E. How fast do both Evie and Max travel? In other words, how many feet do each of them run per second? Express your answers as decimals and attach unit. This is the question that goes back to us talking about rate of change. Because remember the definition of rate of change. We want to know how fast the outputs are changing compared to the inputs. So I'm again thinking about this change of my outputs over my change of my inputs. So when I go to E to start thinking about how to do E, I'm going to be thinking about how is my output changing over how my inputs are changing. Okay, so I'm thinking about this right here. This is my change in my output over my change in my input. So let's do Max's speed first, thinking about this idea of change. So the first thing I want to think about are my change in my output. So what are the outputs? Outputs are the distance. So what's his last output and what's his first output? His last one is 50 and his first one is 0. So I'm going to put 50 minus 0. Change means subtraction. So 50 minus 0 over, what were his change in his inputs? What was his starting time? So this top is distance, and the bottom one is going to be time. What's his starting time? His starting time was 0, and his ending time was this 20. So starts at 0, ends at 20, so I'm going to put 20 minus 0. When I simplify, 50 minus 0 is 50, and 20 minus 0 is 20. And in my calculator, when I put 50 divided by 20, I get 2.5 feet per second. Okay, now let's find Evie's rate of change. Let's find her speed. So I'm going to, again, the idea of my change of my y's over my change of my x's. So again, I'm thinking of my distance on top. And I'm thinking of my time on bottom. So what's her change in distance? Well, she started at 25 and she ended at 60. So I'm going to do 60 minus 25 on top. And her time, she started at the same as Max. She started at 0. Here it's at 0, and up here she ended at 20. So the time for both of them was the same. So 20 minus 0. So when I do 60 minus 25, I get 35. Over 20 minus 0, I get 20. And 35 divided by 20 on my calculator is 1.75. And then I add feet per second. Now feet per second makes sense because what's the distance rated in? Distance is in feet, right? And what's the time rated in? Second. So I have feet over second, feet over second. All right? So to formalize this a little bit, we have a formal definition here. In the first exercise, we're calculating the rate of the function's output, the y values, right? That's the change in y. We're changing compared to the function's input or x values. That was my change in x when I write that little triangle x. This is known as finding the average rate of change of the function. You might think you've seen this before, and you have. Exercise 2, finding the average rate of change is the same as finding blank of a line. We may not have used this yet in this class, but in 8th grade I know you guys have talked about finding slope. So this may be familiar to you as the slope formula, but we're going to give it to you in terms of function notation. So there is of course a formula, and we've just used it in the last exercise. Let's get it out of the way here. It's called the average rate of change formula. For a function y equals f of x, the average rate that f of x changes from x equals a to x equals b. In other words, this is like saying from start to finish. So this is like saying here, maybe the red pen, changes from x equals a to x equals b. From if b is the end, and a is the start. It's given by this formula, f of b minus f of a. This is the same thing as saying change in y over b minus a. The same thing as saying your change in x. Remember, f of something means the y values, right? And b minus a are like your x values. That's why it says x equals x equals. So this is like saying you're taking your end. This is like taking your end values and subtracting your start values, the same as we did before. Your end minus your start. Okay, this is an important formula to memorize. All right. I can give you the example we just did was using, we used that formula here, right? We did 50 minus 0 over 20 minus 0 and 60 minus 25 over 20 minus 0. We did the start, the end minus the start. But let's do some examples that deal with equations and function notation. So exercise 3 says, consider the function given by f of x equals x squared plus 3. Find its average rate of change from x equals negative 1 to x equals 3. Actually, I'm going to use a different color here. Okay, let's use blue. So negative 1 is my start, and x equals 3, that's my end. From x equals 1 to x equals 3. So this is my end value. So let's write the formula down so I know what the formula is. I've got f of b minus f of a over b minus a. This is the same thing as saying what's my change in y over change in x. I know what b and a is because it tells me. The blue and the red numbers are b and a. Those are my x values because I have x on the bottom. So my b value, I'm sorry, I messed this up again. My b value is my end value, and the end value I've labeled as 3. So I know that b equals 3, and I know that a equals negative 1. but I don't know what f of b and f of a is. I have to figure that out using this equation they give me. They give me this equation right here, this x squared plus 3. So my next step now is to find f of b and to find f of a using this formula. So I'm going to plug in for f of b, I'm going to plug in 3, and for f of a, I'm going to plug in a -1 and solve this. So for this first one, f of 3 is going to be, oh my gosh, I don't know how to get my eraser to hotkey. So for the first one, instead of x, what am I going to plug in? I'm going to plug in 3. So I get 3 squared plus 3, which equals 9 plus 3, which gives me 12. For the second one, I'm going to plug in a -1 squared plus 3. -1 squared is 1, and 1 plus 3 equals 4. So that means that f of b equals 12, and f of a equaled 4. Okay. Now I just have to plug these values in. So into my formula, I have my change of x over change in y. Sorry, change in y over change in x. And now, instead of f of b, what am I going to plug in? I'm going to plug in 12. Instead of f of a, what am I going to plug in? I'm going to plug in 4. Instead of b, what am I going to plug in? 3. And instead of a, what am I going to plug in? Minus -1. Okay? Now, I simplify. Be very careful with your signs here. Notice I have 2 minus signs. I have a minus from the formula, and I have a minus from what a is. So I have to be very careful here that I've got 2 minus signs. 12 minus 4 is 8, and 3 minus -1 is the same as saying 3 plus 1, so that becomes a 4. So my rate of change is 2. So my answer, the change in y over change in x, equals 2, and that's my final answer. Okay. Remember, if you're confused, have questions, that's what I'm here for in class. Okay. Let's take a look at a table now instead of an equation. So this says, exercise 4, the function h of x is given in the table below. Which of the following gives its average rate of change over the interval x is between 2 and 6. So again, I'm thinking about 2 being my start value and 6 being my end value. And I'm going to use the exact same formula I used last time. F of b minus f of a over b minus a. That's the formula I'm using. And now I've got to figure out what f of b, f of a is, and what b and a is. Well, it gives me b and a. Always gives you b and a because those are your x values. That tells me that b is going to equal 6, and a is going to equal 2. Now this one is much easier because all I have to do is look in the table. I have to find out, okay, I'm going to look for my, if I want f of 6, my first one, that's this right here. So here's 6. What's its corresponding y value? 3. Okay. Now I'm looking at the a. Okay. What would f of 6 be? Oh, I'm sorry. Not f of 6, f of 2. Right, because we're looking at 2. Oh, I did it again. Oh my gosh. I should just restart this video, huh? Let's try this one more time. Third time's a charm. I want f of 2 because a is 2, and f of 2 is here at 9. Okay, so now I know what all of my things are to plug in. This should have an a in it. Okay. Another way to think about this is, you know that you have x between 2 and 6, so you can think of this as like the point. Okay, I want the point 6, 3, because this is like saying my This is like saying my x value, and this is like saying my y value. Same thing for the blue. This is like saying your x, and this is like saying your y. So this is like the point 2, 9, which is here. 2, 9, 6, 3 is another way to think about it. And now all we have to do is plug these into my formula. The change in y over change in x. Instead of f of b, what am I going to put? I'm going to put 3. Instead of f of a, what am I going to put? 9. Instead of b, what am I going to put? 6. And instead of a, what am I going to put? I'm going to put 2. So I should get 3 minus 9 over 6 minus 2. And now I just have to simplify. 3 minus 9 is a negative 6, and 6 minus 2 is a positive 4. When I put that in my calculator, it's going to reduce to negative 3 over 2. Do I see that as an answer choice? Let me circle it and make it nice. Yes, it is answer choice number 1. Okay. Right. Another way to think about this is you can also think about this as your y2. You might have seen it like this formula. Your change of y over change in x could be like this, where you're basically subtracting your y's, and then you're subtracting your x values, which is what we did here, right? Your x values were 6 and 2, so I subtracted 6 and 2 here. Your y values were 3 and 9, so I subtracted my y values 3 and 9 here. Okay? Alright, let's do the last exercise. Frances is selling glasses of lemonade. The function g of t equals t squared plus 4 over 2 models the number of glasses she has sold, g after t hours. Okay, so as long as she's sitting at the lemonade stand, she's selling lemonade over a certain amount of time. What's the average rate of change at which she's selling lemonade between time equals 2 and time equals 6? So these are my x values. This is my start, and this is my end. Okay, and I'm going to write my formula. I'm going to use g because it's a function of g. So now I've got g of b minus g of a over b minus a. And I know that this right here is my b, and the blue one is my a. So now I just have to rewrite my formula. Instead of g of b, I have g of 6 minus g of 2 over b minus a, which is 6 minus 2. So this is another way of setting it up if you want to replace the b's and the a's and then find out what they are. I know that what 6 minus 2 is, but I don't have g of 6 or g of 2. So those are the two things that I have to find out. So I need g of 6. G of 6 means that I'm going to plug 6 into my equation, this function up here, and simplify. So 6 squared is 36. Carry down the 4 and the 2. 36 plus 4 is 40 over 2. And 40 divided by 2 gives me 20. So now I know g of 6 is 20. But now I have to also find g of 2 for my other one. So g of 2 is going to be 2 squared plus 4 over 2. 2 squared is 4. Carry down the rest. 4 plus 4 is 8. And 8 divided by 2 gives me 4. So now I've found g of 2 equals 4, and I've found g of 6 equals 20, and now I just have to plug those values into my equation. So instead of g of 6, what am I going to have? I'm going to have 20. So 20 minus g of 2. G of 2 I just found out was 4, so 20 minus 4 on top. And then 6 minus 2 on bottom. And now I simplify. 20 minus 4 is 16. 6 minus 2 is 4. 16 divided by 4 is 4. So my change in y over my change in x equals 4. I don't have units because, well, I don't have units. I guess I could say, I don't know what, hours. So if I wanted to say what the rate of change was in units, I could say it's 4 glasses per hour. Okay? Because this is your glasses on top. That's what your output is, and your time is on the bottom. Glasses per hour. Okay? This is a pretty tough lesson, so please ask me for help on the fluency. If you need it, please don't copy the answer key for this lesson because you will have a very, very hard time on your mastery. Alright? Good luck, guys, and you've got one more lesson to go for Unit 5.